ensuite sera suivi d'un commentaire donné par le professeur Bernholz. Please, Professor Tullock.
By anybody's estimation, are we on? Yes. Yeah. By anybody's estimation, the Roman Republic was a successful government, but they had an odd way of making decisions. They would consult the auspices. I'm being sorry to slow down. If I don't get done with the lecture to see if it's his fault, he tells. They would, let us say, look at the liver of an ox, and from that conclude that gods favored or disapproved some policy. They then carried out the god's will. Their success over a fairly long period of time is good proof that even a perverse way of making policy decisions may not lead to disaster. The Romans thought they were getting divine guidance. We now know they were simply getting random outcomes. The point of this paper is that for years there has been a mathematical proof that we are doing something similar. Although many of our policies are set by bureaucracies, our basic dependence is on voting. There is a mathematical proof which appears to show that the outcome of voting is random. As the Romans thought they were getting guidance from the gods while actually getting random advice, we think we get guidance from the people but get random advice. If we consider those people who devote much of their professional time to working in the mathematics of this abstract proof, we find that oddly enough they both prove that democracy doesn't work and believe very firmly that democracy is the best form of government. Orwell will call this double-think. I recently heard a paper by a specialist in the field who remarked that the field was 99% impossibility theorems, which proved that voting couldn't work well. He was, of course, in favor of democracy himself. The people have, Kenneth Arrow, a very prominent economist and Nobel Prize winner, brought the matter out in a form which led to its being widely disseminated. It should be pointed out the basic discoveries were not made by Arrow but earlier people, but he was the one who succeeded in getting many scholars interested in the issue, and he also produced a formal proof, which was not there before. Let me very briefly explain the problem for that part of my audience that are not familiar with it. Suppose we have a tiny little democracy of 3 parties, Mr. 1, Mr. 2, Mr. 3, and they are called upon to choose between 3 alternative policies, A, B, and C. The 3 voters' preferences are as shown on the table. Inspecting the table, we can readily see that if A is put against B, A will win, and if A is put against C, C will win, but shockingly, if C is put against B, B will win. This is what is called a cyclical majority. Most actual voting methods do not permit you to bring the same proposal back once it has been beaten. Unfortunately, this, if anything, makes it worse because which of the 3 wins is entirely determined by the order which they voted upon. Further, any vote on the order of the vote will reproduce the cycle. Thus, the outcome is random. Arrow demonstrated that any voting method, and of course there are many different ones used in the world as a whole, is subject to paradox. One or another paradox is inevitable, hence the outcome might just be the same as inspecting the liver of an ox. I should say that something bothers me more than the formal proof is the realization that there is considerable difference in outcome among many different voting methods that we have in the world today. In other words, Clinton won the last presidential election under voting rules that we in the United States use. If we'd used the method used by Israel or the Netherlands for selection of their prime minister, he would not, even though the votes were exactly the same. This later consideration bothers me, but few others. Sari has recently proved that from any given set of alternatives and a given set of voters with unchanging preference, absolutely any outcome can be reached by at least one method of voting. And all of this assumes that voters vote sincerely and engage in no strategic calculation. This implies that even disregarding stereotype paradoxes, the ultimate outcome depends on rather arbitrary decision of which among the many methods of voting we use. And once again, voting on which method we will use is subject to the same problem. I trust that those of you who are not previously familiar with this will now realize why it at least appears to be a very important problem. A very large number of very good economists and mathematicians have worked on the problem in hopes of finding something wrong with Arrow. I should say here as a digression that most of these people who work on this problem don't come right out and say that what they're trying to prove is there's something wrong with the theorem. Nevertheless, that is what they deal with. The other thing, as you note, that's a rather peculiar arrangement of voters that I put up there, preferences. If you have a very large number of different alternatives, something like this is almost inevitable, although if you have only 3 voters and 3 preferences, it's an unusual combination. This did not bother me particularly, perhaps because I had earlier discovered a very simple proof of the fundamental difficulty in voting pressure, which did not depend on all of the conditions in the Arrow theorem. Nevertheless, all of the people who defend Arrow's theorem so vigorously are confirmed Democrats. The only exception to this, and it's a very modest exception, concerns a conversation long ago with Kenneth Arrow. I raised a fairly standard objection to his program, that is that we didn't observe endless cycling. He responded by pointing out that standard methods of voting, the status quo was always entered into the voting at the end. Thus, if you have a cycle and a status quo is part of the cycle, it will usually win because it's at the end. He remarked that this meant our system was heavily biased towards the status quo. Since he was at that time a socialist, I think this could be contended as criticism of the voting system, but it's the only one I have ever heard from mathematical people. An obvious problem here is that the cycle might turn out to be rare under ordinary voting, and the mathematical work that has been done on it seems to indicate that it isn't. That is, that it's very difficult to work on, of course, but it does seem to indicate that it's common if you simply have a lot of alternatives. And the alternatives are not the ones that are voted on in the final election. Take the American presidential election. We ended up last time with 3 candidates, but normally we have only 2, and with 2 there's no problem at all. But if you consider the number of people who anticipated running for president and were eliminated at some stage in the procedure, the number is 25 or more. And once again, it's fairly certain that the outcome was that if we had preferences, we'd find something like this there. Now, it's frequently said that the priests who conducted the auspices ceremonies of the Romans tended to cheat. This does not mean that they were wicked persons. They made up their minds as what they thought was the best policy and saw to it that that's what the liver of the ox said. It's sometimes said in our voting the same is true. There are people who have control over the order in which things are brought up, and they make up their minds as what's good policy, or I must say, granted that many of them are members of House of Congress, lower House of Congress, they may be using somewhat more less honorable methods of making up their mind, but in any event that they determine the outcome that way. If this is true, of course, that's another fairly vigorous problem of difficulty with democracy. The methods of determining how likely it is to happen are a little difficult. First place, they start by assuming there's a random relationship between people's preferences. If there's not a random relationship between people's preferences, it wouldn't work. But unfortunately, if there's not a random relationship between different people's preferences, we have the difficulty of determining what their preferences are, and particularly for the lower level. It's likely that most people don't really have what we would call a preference function, except on the most important choices that they have to make. They make up their mind between the 2 people who are running for president after they're nominated rather than before, and so you can't really say what their preference was before that came up. But you could, I suppose, say that if their preferences are poorly formed, we should ignore them, but that would mean that whoever makes the decision as to what will actually be put on the ballot would determine the outcome, which is also very difficult. But now let's look at another type of paradox. For example, someone goes into a restaurant and asks what they have on the menu. The waitress says roast beef and chicken. The man replies, "I'll have roast beef." At which point the waitress says, "Oh, I forgot. We also have lobster." The man responds, "That is entirely different. If you have lobster, I'll have chicken." You would obviously come to the conclusion that this man was seriously disturbed. Unfortunately, all known methods of voting are subject to this possibility. It is, in fact, a more general version of the possibility that I talked before. Look at the other program, one over there on the right, and you will observe, if you look at the assume simple voting A against B, well, actually, we'll use the border method here, in which each person gives 0 to their bottom preference, 1 for their second from the bottom preference, and 2 for the top. If all 3 of the variables are there, B will win. But if Mr. C decides he has no chance of winning and hence withdraws, A will win. So this is equivalent to the case in which the decision between roast beef and chicken depends on whether or not there's lobster. And unfortunately, this one is difficult to measure, but all known methods of voting have that one. If any of you have any doubts about this, and we have time after well, you can do it privately, you can state the method of voting you have in mind, and it may take me a few minutes, but I will produce a paradoxical case for that method of voting. It may, but there are good general proofs that it always does exist. Some of the methods for overcoming, what do you do, take the beat? No.
Oh, I put the weighting
Oh,
in.
put the weightings out, okay, fine. But of course you realize when C is gone, the weightings change. Some of the methods of overcoming the Barrow problem seem to be fairly desperate. One proposal, for example, is that everybody might vote for whoever he favors among the number of candidates. The ballots are then all put into a drum, which is rotated. One is pulled out, and that is the winner. Obviously, the more people that vote for any individual, the higher the likelihood of that person winning. Almost the only thing I can think of in favor of this is it does indeed avoid the paradoxes. Examining the liver of an ox also would eliminate the paradoxes. There are also some geometric attacks on the problem, the most important of which is probably Duncan Black, who is the person who first, in modern times, discovered it. It turns out he also discovered there were some predecessors, one of whom was Lewis Carroll, the author of children's books. The median preference theorem. If it is true that all people are rayed from left to right on a straight line, then the median preference theorem gives you a distinct outcome. Unfortunately, this doesn't seem to be true in most real-world situations, but there is a good deal of statistical work which seems to indicate that something rather like this does occur in real-life elections, at least in the United States. In the United States, you normally end up with only 2 parties, and that apparently leads to somewhat the same situation. I wish these things could be repeated by somebody for places where you have multi-party systems. Israel, for example, has, in addition to the 2 big parties, it has a religious party and a Mohammedan party. And these people clearly do not lie on the single dimension that the 2 major parties own. I would guess that the cases where proportional representation is used, and that after all is most democratic countries, not the United States, in fact not any of the ones who speak English, but that this phenomenon would turn up, but it hasn't been proved. Another prospect which I originally proposed is that paradoxes are unimportant because they're rare. In this case, we say that paradox almost always occurs, but is unimportant because it involves a very small difference. I produced a geometric proof of this a long time ago, article called The General Irrelevance of the General Impossibility Theorem. The mathematicians have been unkind to it. There's a difference of opinion here. My view of the reason they're unkind to it is that they have a lot of advanced mathematics and can't remember their high school geometry. And my proof being designed of high school geometry, I think that's why I believed it. But in any event, they are unkind to it. But recently they've begun proving, using very advanced methods, which I don't understand, that in fact it is true. I will, if any of you are curious, I'll cite you the articles which may be possible you can read even if I can't. I stick to my simple Greek Euclid. But if we assume that any member of the legislature can introduce a proposal or an amendment, and that is becoming less and less true in most modern legislative bodies, and there is, the preferences are in a form sort of a cloud over the issue space with some degree of radial symmetry, then according to my proof, which I've said is frowned on, and the more recent work, you would end up with a decision near the center. But it should be pointed out that this does not mean that there is actually a winning proposition. What it means is that you would move into the middle, near the middle of this cloud, but you would never hit a point which could beat all others. There would always be some points which could beat it, but most legislatures have rules that prohibit you from making very small proposals. You have to make sizable proposals. And these rules would mean that wherever you got into near the center, you would stop, because you would not be permitted to make the proposal which in fact could beat that proposal. The other prospect is to try and do something better biomechanics. There's a method of voting which was first invented by Edgar Clark, but I think is more better known because of an article that Nicholas Tiedemann and I wrote, which is a great deal more intelligible to the reader than Clark's work. Clark got his training on writing as a member of the bureaucracy, and this led to a clouding of his reasoning. But in any event, we translated him to intelligible English. That's our only contribution. Briefly, this method requires that people not only tell you their preference, but how strongly they feel about it. Further, although this seems impossible, his method gave them strong motives for telling you the truth. Proposals to let people make decisions with preference weighting have always failed in the past because of the strong incentives to lie and apparent difficulty of preventing it. Ed Clark succeeded in avoiding it. There's another way of cardinalizing votes. That is, cardinalizing votes, these problems don't turn up. These are straight preferences. If we look at any actual functioning democracy, we find there's a good deal of vote trading. I vote for a new dam in your district in return for your agreeing that I can have my harbor deepened. If I may deviate briefly from the text of my lecture, for a long time we had a congressman from Arizona who was a great enthusiast for environmental protection in Alaska, not in Arizona. And the reason he was a great enthusiast for environmental protection in Alaska is that this got him environmental votes for various things he wanted to do in Arizona which did not protect the environment. This is one of the reasons we have something called the Central Arizona Project, which is, as the result of which is the water that I consume in Tucson is both more expensive and of poorer quality than it was before the federal government invested some $2 billion in, quote, improvements, close quote. But anyway, once again, if we look at the real world, we discover this is done with a great deal of regularity. It is somewhat more open in the United States than in most countries, but I don't think we can deny that it always happens in democracies. Parenthetically, I would say it's also of great importance in dictatorships and international relations, although the functioning and the structure are somewhat different. Returning to the main theme here, this permits individuals not only express their preferences, whether they want something or other, but how much they want it, because they can offer further votes or votes on more important issues in return for receiving it. Those of you who have, as I imagine most of you have, followed the passage of the necessary NAFTA legislation through the American House of Representatives will have no doubt have read a great deal about how President Clinton really went to work buying votes by offering a little bit for this constituency and something else for another constituency, etc. Indeed, a sort of record for irrelevancy was reached when a Mexican was brought to the United States to stand trial for sexual molestation in order to buy one senator's vote. But his opponents were doing the same thing. And the only difference between this and what goes on in other legislatures is it was a good deal more open. The United States has a legislative system in which you can see what's going on, not everything, but much more so than Europe. A former student who is a high official in the European equivalent of our Bureau of Budget, and as such has direct access to a great deal of internal activity in his government, and he informed me there's no difference between what they do and what American politicians do, except the newspapers don't report it. If we turn back to Orwell's original book, we'll find that he says specifically that his theorem does not apply if there is such log rolling. I found this in the book at about the 20th reading. The fact that I missed it the first 19 times shows that it's rather obscure. But I wrote an article and got it published, sent, of course, a copy to him, and he told me that he was going to reply. He said it was an important comment and he was going to reply, but because it was important, he would have to be careful about it. And that was now 5 years ago, and the last time I saw it, he said he changed his mind about replying. So I deduce that my comment is at least correct with respect to his book. That doesn't, of course, prove that the ultimate decision is correct. For some obscure reason, this phenomena in English is normally called log rolling, and I think it's not much talked about most places except the United States. Further, there's a sort of general feeling it's not a good idea, although I'm willing to argue that it produces a better outcome than you can get without it. To repeat, a similar phenomenon occurs in dictatorships. It's not characteristic only of democracy, nor is it characteristic of American democracy. As far as I know, the first theorem analysis was my own problems of majority voting, but that it did exist and that the general effects that I found in that article were pretty well known by the bulk of political scientists. The end product of all of this is that we have a formal mathematical proof that democracy is a random number generating process. I think that this is true only in the sense that the absolute final decision is fixed. That is, that there is some another proposal which is a little bit different, which could beat it, but which isn't very important. In other words, the voting brings you into the center of a cloud of possibilities, but does not actually determine the final point. I take it that Professor Arrow does not agree with me on this, although since he has not replied to my comment, I can't say exactly why he doesn't agree with me. But if I am right, the Arrow theorem is absolutely correct as a bit of mathematics and not quite totally irrelevant to democracy, but very close to totally irrelevant to democracy. And hence, I would suggest that we forget about it and go to work on other matters. There are a lot of people engaged in devoting a lot of intellectual effort to this, and I think that they should stop. And I stop.
Nous sommes très heureux d'accueillir le Premier ministre de la République tchèque, M. Václav Klaus. Il faudra encore patienter un petit peu pour l'entendre, parce que nous allons suivre le fil des conférences. Et après cette analyse très pointue du professeur Gordon Tullock, nous allons écouter le commentaire du professeur Bernholz. Et ensuite, nous passerons, disons, à la version moins analytique sur le plan de l'économie stricte, et nous verrons l'opinion d'économistes professionnels, mais qui sont familiers maintenant des mécanismes politiques. Alors nous aurons des versions, disons, différentes et peut-être aussi optimistes pour l'avenir. Please, Professor Bernholz, would like to give your comment on the paper from Professor Tullock.
Well, thank you very much. I should say that I mainly agree with what Gordon has said, especially as to the nature of the formal proofs. Having worked in that field, however, I have to make a few critical comments and to ask one question. The first I should mention is that I am still, like many others, not so sure that the decision will lead to the center of the cloud, Gordon. I think that it is not only the dislike of geometry which has brought some people to doubt that, to put it mildly. The second point is I want to make a question, or put a question to you, namely, how would you bring into the picture the theory of probabilistic voting? The theory of probabilistic voting says that, for instance, if the voters don't know exactly the position of the candidate, then the paradoxes will not arise. So perhaps you can comment on this. On the other hand, I have some doubts on the cardinalization, not as far as the Clark paper, this approach is concerned, but as far as the vote trading or log rolling approach is at question. Log rolling or vote trading is in fact very important. We all know that most of the important decisions are now really taken in small committees of parliament or of the Congress. And here, of course, a lot of log rolling is taking place. This is well documented for the American Senate and House of Representatives, but I have heard similar stories about the two houses of parliament in Switzerland and so on. So it is probably not as well known in Europe, but I guess it is there. Now, if you look at log rolling, Gordon seemed to point it out that because you have a market in votes there, you might have some beneficial outcome because the votes here can be weighted because they are sold in a way. Somebody purchases votes, and of course, if one vote is more important to another one, the other one may promise several votes for the one vote or whatever it is. So that's the idea behind it. Now we know, however, that this works only if we have a perfect market. And here we have a very good theorem by James Coleman, who really shows that if we have a perfect market, it works in the way Gordon mentioned. But unfortunately, I think we have not a perfect market. And even if we have in real markets an oligopoly, we can show that we have similar problems there. And that actually this is also a case of the arrow theorem. Let me point out in this relationship that I absolutely agree with you that log rolling is a substantial interpretation of much of the arrow theorem. I personally think even that log rolling or vote trading comprises the voting paradox to which you have drawn our attention. And you yourself, Gordon, have mentioned earlier the distinction between explicit and implicit log rolling. Implicit log rolling is present if parties, for instance, put together a bundle of issues and present them to the voters. But this is always the case. You see, we have not to vote on everything, but only on the programs which are presented by parties. And since they are bundling together several issues, it is as if they would do vote trading among the voters they want to win. And therefore, log rolling is, in a sense, the more general phenomenon. But to come back to the imperfect market approach to log rolling, then we have cycles. We know that quite well. And this means, however, since only a few people are usually involved, there is no instability. You have written yourself this earlier paper, Why So Much Stability? And I myself have argued even before that paper that we have a repetitive game as soon as there are only few people involved. And then, of course, if you have a repetitive game under certain conditions, if I make an agreement, let's say, as a senator in a committee, then I have to stick to that agreement. Otherwise, I will become untrustworthy and will never be able to strike an agreement later on. Therefore, we get stable outcomes, but which outcome we become is a matter of chance, or let's say of the leadership of an important person in the committee who sets up the agenda. So it depends on this personality. So we have still a somewhat black picture. Well, I think I should only say that as a consequence, we have really a problem, and I personally think that the paradox, apart from this stability which can be introduced, but which does not solve really the underlying problem, that it can be only excluded more and more often if we move towards more and more qualified majorities. With unanimity, of course, it cannot happen. If we come near to unanimity, it will not happen very often, and so on. I think I stop here because of shortage of time.
Maybe we have time for some questions from the floor, but before, is there some reaction of Professor Tullock to the comments?
This is somewhat embarrassing because we are in great general agreement, and that makes it difficult for me to respond. I would say, however, that I do think that log rolling leads normally to a specific outcome, although it does depend on personality and so forth. But the problem is that this output is inferior. If we raise the required voting majority, in theory, to unanimity, which is obviously impossible, we would provide an outcome which is better. Of course, you get any outcome at all becomes less and less likely as you increase the number of voters.
What about probabilistic voting? Probabilistic voting.
Y a-t-il des questions maintenant dans la salle? Oui, monsieur.
Merci. Je m'appelle Ioan Dragoș Mirica, je viens de l'Université de Bucarest, Roumanie. J'avais une seule question à vous poser à Monsieur Tullock. Excusez-moi, je ne peux pas parler en anglais. La question c'était, par exemple... Je connais pas l'anglais, excusez-moi.
Vous parlez lentement pour que la traduction puisse se faire.
D'accord. Donc, prenons l'exemple d'un électorat très dispersé, donc il y a un champ très large de préférences. Est-ce qu'il faut toujours analyser le comportement de l'électeur médian, s'il y en a un, bien sûr? C'est ça ma question. Merci.
I regret to say that my principal comment is I only got this started just as you were finishing. So I'm sure your remarks were penetrating, brilliant, etc., but I didn't hear them.
Répétez la question.
Now we don't have any excuse, Gordon. Listen.
Bon, donc je recommence. Prenons l'exemple d'un électorat très dispersé. Donc il y a un champ très large de préférences. Donc dans ce cas, faut-il prendre encore en considération le comportement de l'électeur médian, s'il y en a un? Merci.
I think we are still having a certain amount of difficulty because I think our technical language is missing the translation. So, is it important?
I tell you what is.
Okay, fine. Okay, now I know. The answer to that is it depends on whether or not they are arrayed on one dimension. If they're not arrayed on one dimension, the median preference theorem fails. But statistical work in the United States has shown that in the United States, you get something very similar to it. But I believe the reason for this is the two-party system. And I think that if you were using proportional representation like Switzerland is an extreme example, you would be no point in worrying about the median preference. Unfortunately, median preference theorem is at least determinate.
Well, perhaps I should add a little bit to make it better understood. If we have several issues on which people are interested, there may be different median voters for each issue, and this brings about a difficulty.
Other questions on these technical points? Maybe we will make now just a break, a 10 minutes break, no more, because then we have other lectures. Just 10-minute break.